wonder a lot about science. It's everywhere. But what is science in the first place? Sure, it's a body of knowledge, but how is it different than other ways of knowing? Well, science is a way of knowing and understanding the natural world, which has order and consistency. But it isn't the only way of knowing because there are other things such as philosophy and religion. What makes science science is that we're limited to things we can observe. Science isn't an answer book. We can't answer things that lie outside the realm. We can only provide evidence and data. For example, two heated debates right now are issues regarding abortion and gun control. For abortion, science cannot define life in a useful way because people have different truths for this. Does life start at conception or birth? Science doesn't have an answer. For gun control, which is better, more strict regulations or less strict? There are pros and cons to each regarding safety versus freedom to bear arms, but science cannot measure freedom in a quantitative way. It can only provide data. We depend more on our faith-based beliefs to guide us, and we choose for ourselves what is right and wrong. So now we know what science can't give us, but what can it provide? Like I said earlier, science is based on the natural world, which we use observations to show what is happening, and then we use explanations such as hypotheses and theories to answer why. Let's put this on a matrix to make it more clear. I'll use giraffes as a guiding example. So when I see a giraffe with a long neck, I can say, that's a fact. I can observe that. But if this applies to all events, then it's a law, which usually has some mathematical component to it. We'll get back to this later. But this doesn't explain why giraffes evolve long necks, so we move on and create a hypothesis. A hypothesis isn't a guess. It's a tentative explanation for why something is occurring. So I can develop different hypotheses as to why giraffes have long necks, such as feeding purposes, so they can eat leaves off of tall trees, or for sexual selection. We can then build up all these different hypotheses over and over again until a theory is formed, which explains all of that. So in 1800, Jean-Baptiste Lamarck created the first theory of evolution. He basically said, species evolve up a ladder to keep up with environmental change. You don't go extinct. Giraffes stretch their necks to reach the leaves so they can get longer over time. The organism is getting better. However, he had a lot of holes in his theory, and we know this way of thinking isn't true based on today's evidence. However, this is still a big misconception today. Then, in 1859, Charles Darwin created On the Origin of Species, which explains natural selection, aka the process for the theory of evolution. Note that he initially applied this to atolls and coral reefs, but we'll continue using giraffes. His theory wasn't perfect though. In 1865, Gregor Mendel made a paper and explained particulate inheritance. He created 3 different laws for inheritance, known as the law of segregation, law of independent assortment, and the law of dominance. But it was completely ignored because of the math. It was unappealing and complex. However, in 1918 to 1932, Darwin's theory and Mendel's ideas were revisited and mashed together by Ronald Fisher, J.B.S. Haldane, and Sybil Wright. Each contributed different ideas, and they were responsible for the modern synthesis, which combined Mendelian genetics and the theory of evolution to create Neo-Darwinism, or how we know evolution today, which showed the pattern and process. This shows that science is practiced within a much larger community and isn't a solitary activity. They invented population genetics, math, which explained the change in gene frequencies in populations to explain evolution. So, in all, evolution is driven by natural selection, acting on variation, made by mutations and genetic recombinations, or chromosomal crossovers. Going from Lamarckism to Darwinism shows that science is tentative and theories do change in the presence of new observations and data. So we study and observe giraffes, gathered data, and found evidence that males with longer necks actually win fights and obtain higher social status, which create more mating opportunities to them. This allows them to pass on their traits because they survive and reproduce better than those with shorter necks, because populations evolve by the deaths and births of individuals. As a side note, giraffes actually bend lower to eat, not higher, so next time you see a children's book supporting old ways of thinking, you might want to reconsider your purchases.